In this video, we are going to look at different examples of rigid transformations. Now, a rigid transformation is just another way of saying that when we do these transformations, they stay the same size and the same shape. There are three transformations that we will be looking at in this video and this unit. They are a translation, which is a slide, a reflection, which has a line of reflection, and then a rotation, which is when you turn an entire figure about a point. When we perform these transformations, the new figure is often labeled with something called prime notation. You'll see that listed here as A apostrophe. We read that A prime, B prime, C prime. So you can see the image, the new point, the point that was transformed, the image of A is labeled A prime, the image of B is B prime, and the image of C corresponds to C prime. Let's take a minute and perform some of these translations. Now this particular problem asks me to translate EFG 3 units to the left and 4 units down. So I'm going to start with point E. Every single point, E, F, and G, will be moved this same way, 3 to the left and 4 units down. So I'm going to start with E and count 3 to the left, 4 units down, and then I'll repeat for F and G. When I'm done, I'm going to make sure that I label my new image E prime, F prime, G prime. All right, now let's move on to reflections. In this example, I'm asked to reflect ABC across the y-axis. So first, I'm going to realize that the y-axis is my vertical axis, and then to perform this reflection, each point on the image must be the same distance from the line of reflection as the point on the original. So I see that A is 1 point to the right of the y-axis, so A prime is going to be 1 unit to the left. I'm going to measure the distance from the axis for B and put B prime at that same corresponding distance. And then I will repeat again with C and C prime. When I'm done, I'm going to make sure that I have them labeled A prime, B prime, C prime, and I have my image of my figure drawn. In this example, we're going to look at reflecting ABCD across this graphed line, which is given by the equation y equals 3. Now, I really like this problem because some of the vertices of the shape are on the line, some are above the line, and some are below the line. But again, what I'm going to do is I'm going to count the distance that A is from the line, and again, that should be measured perpendicular to the line. So this is a horizontal line. I can see A is 1 unit below the line. A prime would be in that same corresponding spot, 1 unit above the line. B prime is 2 above the line. It gets flipped to 2 below the line. Same with C, and then D remains in its spot on the line. I'm going to go ahead and make sure I've labeled those A prime, B prime, C prime, D prime, and then connected the sides of my shape. This example is a little bit more interesting because I can see I have a diagonal line here given by the equation y equals -x. So in order to perform my reflection here, I need to make sure that when I connect the point to its image, that line is perpendicular to my line of reflection. So I'm going to start by taking a look at A, and if the slope of my line is -1, I know the line that connects A and A prime must be the opposite reciprocal of -1, which is 1. So I'm going to go ahead and graph a line of slope 1 through A, and that's going to help me find my spot that's equidistant and in the right position. I can see that I'm 1 diagonal's length away from the line, so I'm going to go 1 diagonal's length on the other side of that red line to graph A prime. I'm going to repeat this process for B. I'm going to draw a line with a slope of 1 that goes through B, and then I'm going to go equidistant on the other side of the red line. And then again, I'll do the same thing for C. I'll draw a line with a slope of 1 that goes through C, because again, that's perpendicular to my given line of -1 slope. And then I'm going to count and make sure I'm equidistant on the other side of that red line. And then I'm going to make sure that I go ahead and connect my sides, include my prime notation in my answer. All right, the last transformation that we're going to look at is a rotation. Now, in this example, I'm going to be rotating triangle ABC 90 degrees clockwise about the origin. Just like in a reflection, you have to have a line of reflection. In a rotation, you have to have a point at which you're rotating the shape about. In this case, it's the origin, and we're going to go clockwise. So that means every point A, B, and C is going to be moved 90 degrees clockwise about the origin. Means the distance from the origin is going to stay the same, and it's just going to get shifted 90 degrees in a clockwise direction. I'll show you what I mean. So if I look at A here, that's at the point 0, 2. A 90-degree shift is going to put that over to the right at 2, 0 for my A prime. And I can see when I connect A to the origin to A prime, it's going to make a 90-degree angle. So I can use that and slope triangles to help me visualize and see where my shape will end up. So now let's look at moving point B. Since I know that B connected with the origin and then to B prime must make a 90-degree angle, I'm going to go ahead and connect B to the origin, and I can see using a slope triangle where B prime would need to end up. It would get moved to the point 2, 2. And lastly, let's move point C. When I connect C to the origin, I can see that my slope triangle is down 5 over 2. So to find out the location of C prime, I would want to move 90 degrees clockwise. Using a slope triangle, I would be up over at over 5 up 2. And that would give me the location of C prime that would make a 90-degree angle and thus completing my 90-degree rotation.